Hi, I'm Addison. Today we are going to talk about multi-threading on x64 computers. Back in the days of P4 processors and earlier, multi-threading was handled with only one processor core, and the processor ran multiple applications by task switching, and while this worked okay, you were limited to the capacity of one processor core. The P4 had the option of hyper-threading that allowed two threads to run, with some independence. But it was not until the Core 2 series that multiple core processors became available with most computers. In modern times, 4-core, 8-thread processors are common, and with more recent processors from both Intel and AMD, much higher core counts are available.
A large number of existing applications are single-thread designs, and while this works okay with simple tasks, with tasks that have to handle much larger volumes of data, parallel processing using multiple threads start to utilize the multiple cores in more recent processors. This involves a paradigm shift from older linear designs that came from the real-mode era to conceptualizing multiple parallel processing. And while this sounds complicated, if you have used Microsoft Windows for any length of time, you are already familiar with multiple tasks that run at the same time.
Hi, I'm Beatrix. The layout of a multi-threaded application starts out very similar to a single-threaded application, as an executable file must have an entry point so it can start. Once the application has started, code can be written to create other threads, and this is an area of great diversity depending on the task that is being undertaken. At its simplest, you can start a thread to perform a task, and then exit when finished. This is well suited for loading and saving files. Alternately, you can start a thread in a suspended state, run it later, and within the thread code, suspend it again until it is needed again. You would use a design of this type if you need to be able to run it multiple times. If you were writing a more complex application like a web server, where you have multiple connections, you need a single thread creation procedure that can be used for each new connection coming in, and it needs to wait between each thread that is created so that the next thread does not overwrite the previous thread's arguments. Usually a thread of this type should signal the calling thread that it has finished execution, and then terminate.
Howdy, I am Billy. Addison has asked me to write some code to demonstrate how to use multiple threads in an executable file. The first example is a simple and easy one to follow. It's the file I/O for an application that starts life as a single-thread application. The code shown here is taken from the WinProc, which is usually triggered by either a menu option or a toolbar button. The two procedures that they call are deliberately written to be self-contained, which keeps the open and save calls simple. With each procedure, they are run once, then they exit, which keeps them simple to understand and use. Now this technique works fine in a single thread, but if the task it undertakes is of long duration, it locks up the single thread until the task is completed. With only minor modifications, we can convert this single thread code into independent threads which run asynchronously to the calling thread and solve the problem of locking up the calling thread. We start by writing 3 64-bit variable to the uninitialized data section. They need to be global in scope, because normally the local variables in calling procedures cannot be accessed by a procedure in a different thread. One is a flag to ensure that the same thread cannot be started while another thread is running. The second is a handle for the thread, and the third is a thread ID, that is used in some contexts. This is the create thread code that replaces the original direct calls to the open and save code. It has the additional test to see if the thread is already running, and if it is, the thread is not started. The close handle API is run directly after the create thread, so that the thread will run to its end then exit, and the cleanup is automatic. Modifying the two thread procedures is very simple, as they become something like a callback specified by the system. All you have to do is add an empty argument so that the procedure conforms to the operating system specification, and it can be called by the thread creation code in the WinProc. Do these simple modifications and you now have an application that has fully threaded file I/O.
Thanks, Billy. We will do some of the more complex ones later. See you next time.